Who said that? Hey, all right, yeah. All right.
At least you didn't take our weird.
Yay. I had some random person write to me on YouTube and say, your videos are not very helpful. I'm like, you're not one of my students. I'm not Khan Academy. What the hell? I want my hands. No, we're gonna. No, it's not me. All right, so 1F. This is like 1F. So if I said I to the, let's see, which one, Jeff? 120 third. So there are a couple different ways to do this kind of problem. To me, the way that I showed you is the most direct way to get there. 4 goes into 123 how many times? 30. Yeah, that part doesn't even matter. 4 goes into 123, but how much left over? Can you guys all see? 4 would go into what number right below 123? 120. So how much would be left over? 3. So this is the same thing as I cubed. That's the idea. Because it repeats every 4. So if you divide by 4, the remainder will tell you where you are in that pattern where it just keeps repeating the first 4 values. And so now you just got to remember what the hell I cubed is. Negative I.
If 4 goes into it evenly, why would it just be out of the 4th?
It totally would be.
Right, you want to put I cubed. Oh, you're just using it.
No. 4 didn't go into 123 evenly.
Oh, I thought you said it went at 30.
It would go into 120 30 times, and there would be 3 left over. Or 30 times, yeah. So what matters is the remainder that you would get once you divide by 4. Why 4? Because that's the length of the cycle. Okay.
So you wouldn't do it by 3, right?
Yes. What?
So you wouldn't do it by 3? You said you have to do it by 4.
Because how long is the cycle that it takes to get through all of its terms, all of its possible values takes how long?
So
4.
So there was like, let's say it was 127 instead of 123, would you still do the 4?
Yep. You always divide by 4 because the cycle is every 4. That's all. Yeah. So I to the 5th would be I again, because what I to the 4th is 1. When I multiply by 1 more I, I'll get 1 times I. It starts at I again. So 4 later, it starts at I. 4 later, it starts at I again. 4 later, it starts at I again. It's like saying later. Does that make sense?
Yeah.
I mean, is everybody cool with these first 4?
Yes.
No. If if you have 5I, doesn't that mean that 5's a negative?
No.
Alright.
What does I by itself represent? Doesn't that represent negative?
No. Yes.
It's further negative.
Okay.
So it's the square root.
So I is defined to be the square root of negative 1.
Oh.
So this first step seems really silly, but it just establishes that it starts at itself, right? I to the first is I. I squared, because it's defined to be square root of negative 1, when you square it, you're going to get negative 1. Right? How we doing so far? Okay. I cubed is going to be, I cubed would be I squared times I. Is that cool?
Yep.
Because you would just add the exponents, right? And why would I do that? So I can build something I don't know from things that I do know. I do know what I squared is.
Negative 1.
Negative 1. And I do know what I is. It's I. So I cubed must be negative I. So then how would you get I to the 4th? Well, the easiest way to get I to the 4th is I squared times I squared. Again, building off of stuff that I already know. And what's I squared?
Negative 1.
Negative 1 times negative 1 is?
1.
1. So that establishes this basic pattern. So how would you get I to the 5th? You have to take I to the 4th and multiply by 1 more I, right? Is that cool? I'm just kind of building. So to get I to the 5th, what's I to the 4th times I? It's 1 times I. What's 1 times I? I. So it starts at I again.
Because it's only 1 left, correct?
Yes. It's I to the 1 now.
The remainder is 1.
Oh, sure. But don't even bring that into play yet. I'm not even talking about that yet. So the remainder idea comes from just noticing this pattern. Every 4, it starts over again at 1. So I6 will be negative 1 again, because it's going to be I times I, which is negative 1.
Another question. Okay, so for instance, you have 2I, that's just 2 times I.
I squared?
No, yeah, okay, we'll start there. If you have 2 times I squared, that'd be negative 2 would be your answer.
Of course.
Correct?
Sure.
2 times I
I cubed.
to the cubed would be
Negative 2I.
negative 2I. You just gotta add
The
I.
2 just comes for the right.
It'd be negative 2 and then I. The negative goes in front of the 2. And then
Yeah,
if you
yeah.
got 2 to the 4th, it's just 2.
Because, what's twice negative 4?
Negative 8.
Negative 8. You put the negative in the front, don't you? Right? So twice I cubed. What's I cubed?
I want minus I.
Negative I. And what's 2 times negative I?
Minus 2.
Negative 2I, yeah.
Alright.
Alright.
Also, if you want to do one more, something like number 1, I know it's simple.
Part A?
1A, yes.
Okay. Because number 1 is like the whole thing. Okay. Alright. And again, what's the most important thing in this whole board?
The 4. And the negative 1.
Yeah, this is the most important thing. Because that's the one that occurs the most often, right? In fact, normally if I'm working at a problem and everything starts at an I level, I'm not going to even let it get to these powers. Because every time I see an I squared, I'm going to replace it with negative 1.
Are we doing it from the practice test? The 1A that you're going to do?
No, it's from the quiz you're talking about, right? Yeah.
Quiz, yes.
Yeah. Okay. Oh, real quick, before I get too far away from this, 2 things. Before I say something, let me make sure I have some with me. Shoot. Yes, all right. Emmy, need a copy of the practice test now that I know I have some. Holy shit. All right, let me see. Okay, let's hope I have enough. Let's see what happens. Yep, practice test. Okay. Alright, and there was actually, I got a handout I forgot to give out last time that talks about a little bit about the negative b over 2a thing. Oh, understood. Alright.
Did you have to miss it all?
Oh, okay. Good. Okay, so 1A. Alright. Nobody had this, but everybody had this on 1A. Bless you. What's the only piece of this you really have to be careful about?
Within
Some of us weren't, yeah. So the negative's got to go through. So I'll have 17 minus 5i,
Minus 2I plus 4.
yeah, plus 4,
Plus 5.
plus 5 minus 7i. And then you just get your like terms together. Yes, sir.
Why did you put it all in parentheses like that? What was the function of that?
One of the parentheses is totally necessary, and the other 2 aren't. But what they're really doing is saying there's one complex number minus another complex number plus a final complex number, right?
That's what threw me off. I was thinking that I got a flow.
Come on now, come on. So, I mean, back in the day, you would get a problem like this. Maybe something like that, whatever. You just take the parentheses away if there's a 1 out front, right? So, don't say, why did you put parentheses there? You don't need them. I'll say to you, take them out when you know you don't need them, right? So here I needed it. I had to have it here because it's minus both of these pieces, right? The other ones I agree, you don't need them, so what's the first thing you do?
Take it out.
Take them out. But the reason they're there is to kind of show you that's one complex number and another one and another. There's 3 complex numbers that I'm putting together. Right? But to put complex numbers together, you put their I parts together with their real parts. Right?
How come you would distribute the plus?
I did. What's a positive times 17? Or what's a positive times 5? 5. What's positive times negative 7? Negative 7. Right? Because there's a 1 out there. So the only one that's going to matter is this guy. Negative 1 times something changes its sign. Yeah, cool.
Okay, I was going to ask that same.
So that problem is exactly the same as this problem.
I think it helps if I would imagine there's a 1 in front
Yes.
of that.
You can always just write a 1 right in front of that bad boy there. Yeah. Cool. Yeah.
So isn't it 26 minus 49?
For this one?
Yep.
So let's see, we got 17 plus 4 plus 5. Good, that's 26. Then we got negative 5 minus 2 minus 7. That's minus 14i tickets. For that problem. All right, don't copy that down for your answers. You don't have the same problem. Yeah, try. E? E, right? Yeah. Sure? No? No. You're okay, Trent. I don't know what that... It was a very strange little moment there we had. Alright. So this is one like, 1e. Okay. Okay. You guys all know what to do. You even know what it's called.
Conjugate.
Yeah, conjugate. The thing I saw a little too much of is when you multiply by the conjugate, what is the purpose of it?
To get rid of the I on the bottom.
Beautiful. To get rid of the I on the bottom, not to get rid of the bottom. This times this is not 1. You can't just cross them out. Right? So, not a lot of people, but a few too many people do that. So it doesn't do that. What it does is it makes the bottom real. Right? That's the purpose of it. If it was radicals, it would make the bottom rational. So now we're even going beyond that. We're making the bottom real. Does that make sense, Trent?
Okay.
You alright? So on the bottom I get 36. And the middle terms cancel, right? We designed it to work that way. Yeah, minus 4i squared. So you have to worry about that I squared in the next step, right? The top, so I'll keep people, of course you got to FOIL this bad boy out. You can't just do this and then this and be done with it. So you get
24.
oh, 8y. Yeah, plus 10i squared. So now, I have definitely like terms up there, but there's one more thing I could do, of course. Yeah, you can combine it like terms, and there's one more thing I can do.
Negative 1 in the I.
Yeah, the I squares are negative 1.
Negative 1.
Yeah. I is not negative 1. I squared is negative 1. So you get 24 plus 38i minus 10. Good. 10 times negative 1, so minus 10 over plus 4, right? Minus 4 times negative 1 is plus 4. And this is definitely multiplying, right? So a couple of people would tell me this is negative 5 because they thought it was negative 4 minus 1, but it's times negative 1, so it becomes plus 4. And now you just simplify and you're done.
14 plus 38.
Yeah, 14, yeah, plus 38i over 40. And you can stop there. You could break it up and reduce it, but if you stop there, you're okay. You see how everything is divisible by 2? So I have one more step you could go. Yeah.
Can you go over 1C as well, please?
So if I have, I'm kind of running out of square rootable numbers here.
What point
I can't remember what I used. What is the square root of negative 36? There you go. See, 6i.
And 7, right?
6i, and then 7i. What's 6i times 7i? 42i squared, and then what's I squared?
Negative 42.
Yeah, so the 42 times negative 1 is negative 42.
What? That's it. Yeah.
I'm sorry, it's that simple.
No, it really looks a lot harder on the quiz.
So everybody had a problem just like that. You just had different numbers inside. But you can't multiply these together and kill the negatives. You're just not allowed to do that. It's because this ends up, if it was square root of negative 1 times square root of negative 1, that's like I times I, right? So you can't just cancel the negatives. You're sort of like ignoring that they're complex, and you can't do that. You have to first really make it, oh, it's complex. Oh, it's complex. And then you can go forward. You can't just go, I'm not going to even look at the complexity. Just let the complex go part go. No good. You gotta do that first. Say, oh shit, it's complex, and then you can keep going. Maybe. Okay. So.
Can you do one
Yes.
on the practice test?
Sure.
Can you do F, 1F?
Yeah, that was a little freaky. But I didn't mean it to be too freaky. So everybody want the one from up here? Everybody got that? Yeah. Thanks, Carl. So nice. That's what I say. Alright. So, 1F on the practice test.
Are you giving us it?
Huh?
Do you have to copy it?
Sorry? Oh, yeah, I'm going to give it to you.
Oh, so we don't have
It's not yet.
whatever.
Plus 2?
Yeah, so the only real reason I gave you this problem is nothing really major. If that was squared, I would do everything the same as we're about to do. If it's to the 7th power, I do everything the same as we're about to do. Right? So, yeah, add 2. Cube root. Now, here's the trick, though. Since it's a cube root, do you have to put a plus or minus?
No.
Hell no. No, it's only the even roots that have weird problems like that.
What do you want to prove yet?
Oh, angry coffee. Alright, x minus 1, cube root of 2. Is that cool? We do the cube root just to kill the cube. Right. And then sort of the last step, you could do...
You don't have to simplify?
Yeah, you could do that. Right. I mean, add 1 at least. And then if you notice... I wouldn't take points off for this, but if you notice, what can you do with the cube root of 16? Is there a part of 16?
8 times 2.
Yeah, 8 I can cube root.
Okay.
So this will be...
2.
Yeah, cube root of 8 times the cube root of 2, right?
Yeah.
Because this piece now is
2.
2. I think in the answer you can just stop there. It's a good time. But if I would have put a 7th root, everything would have been the same except I would stop here because I can't do anything with 7th
But
root.
just why we didn't cancel it to keep it there? Like,
I did
yeah,
cancel.
the other side too. Like,
What would it
we
cancel with?
canceled,
What would it
like,
cancel with? Here it cancels because there was a cube there, so they cancel. Over there it says correlable 16, unprotected, right? So the cube root, nothing kills it. Yeah.
Can you do 1C?
You have a question with this?
You don't add 1 plus 2.
Definitely not, because this is 1 plus 2 times cube root of 2. So this and this, they're not like terms.
Do you have to finish it? Is that the, you want it complete?
Yeah, if you left it like that, I would have been okay.
Yeah.
But technically, that is simplifiable, right? So then you simplify it down.
So you broke the.
Yeah, that's old news, right? Cube root of 16 has got a part of it that I can cube root. So I break it into cube root of 8, because that can be done times the cube root. Isn't that cube root of 16? There you go. So it's sort of like the square root of 50, 25 times 2.
Oh.
That exact same idea.
Oh, okay.
Cool.
Okay. All right.
But I would have been okay with this. The main idea I wanted to get there was no matter what the power is, you attack it the same way. You take that root eventually. Yeah.
Thanks for pointing that out. I was like, how did you do that?
Certainly. Yes.
Can you do 1C, please?
From the practice test?
Yeah.
Okay. Oh, good. All right, that's definitely one I want to do. So this practice test, I think, definitely qualifies for a bit harder than the actual test is going to be, if you were wondering. What I want to do with you guys. Let's see. Let me ask you a preliminary question. Does that look all right?
Beautiful.
Yes.
Looks good.
All right. I'm going to head out now. Obviously, done nothing.
No.
Well, how do you square something? You multiply it by itself, right? So is that? Hell no. What's that missing? Middle term, right? So this is the idea I keep saying. I desperately, you cannot play with, these guys are play well together. Exponents cannot distribute across addition because exponents are not based on addition. Right? Whereas coefficients, what's 2x really mean? It means x plus x. I really want you to get this. Coefficients are based on addition. So what's twice x plus 2? That I could totally do that with, right? Because coefficients will totally play well with addition. Because they're based on addition. Exponents, no, never in a million years. You got to write like this just to get away around that. I can't bring the 2 in like that. Because exponents are not based on addition. But why can I bring that 2 in? Because coefficients are based on addition. I really want you to keep that. So it's exactly the same thing as when somebody tells me that the square root of 4 plus 9 equals 2 plus 3 equals 5. But what is the square root of 4 plus 9? Square root of 13. Does that equal 5?
No.
So that square root cannot distribute just like that power. Because I know it's a 1/2 power. It cannot distribute to the 4 and the 9 because it doesn't go with addition. But my calculus 2, my math 280 students do this. It drives me insane. You want to make your math teacher cry and do that at that level. Right? I seriously shed tears as I graded these things like, okay, how did you get here? But you guys, I can understand, it's really, you're learning so much stuff, it's so dense with stuff, that you start to mix some of it up. I can understand that, but I just want to keep pointing this out. No, you just can't do that. They don't play well together. Alright? So, why did I point all that out when we're supposed to be doing this problem? Because what you would normally try to do right away is you try to square both sides, right? And that would be so desperate, but you can't just put a square next to that guy. You'd have to FOIL this thing. Do you want to do that? No, I don't want to do it either. Do you see what I'm saying? The same way you'd have to FOIL this, write it next to itself and FOIL it. You would have to write that next to itself and FOIL it. So the only way to make this a little better, because how many radicals are in there? So how many times do you think I'm going to have to square it? Twice. So I isolate one radical so I can at least kill it. I'm still going to have a radical left somewhere. And then I'll isolate the other radical, and then I'll kill it. Right? It still sounds like how to run a dictatorship. Isolate the radical element, kill it. Right? I'm not sure what that accent is, but it's just supposed to be generally equal sounding. I don't know. So I would add this part over. So I get square root of 3x plus 1 equals 2 plus square root of x minus 1. Yes, sir?
I mean, since they are multiplication, one thing, I think it would be easy because they are square roots. So multiplication, when you FOIL, will cancel.
But not all the way. You'll still get something in the middle that'll be a combination of the two square root inside. So it'll still work. You're right. It'll still work, but it'll be uglier than it needs to be. Right. So I'm not saying it won't work. I'm just saying it'll be really kind of gross. But you're right. That'll cancel with itself. That'll cancel with itself. But then the middle term would be a combination of those two. Do you see what I'm saying? And that would be really a lot worse than it has to be. Yeah. So, some of you guys are like, well, that's not much of an improvement, but it's too damn bad. But at least now when I square this side, it just directly kills that. But what happens when I square this side?
You have to FOIL.
I have to FOIL. Beautiful. But at least now it's not two radicals in one. And this is where people kind of give up. You don't even try it. You know how to FOIL. Don't freak out just because there's a radical inside there. You know the process for FOILing. That's the most important thing. Then it shouldn't matter what I throw in there. Just apply the process to it. So let me write this twice. That's exactly what we have to do here, right? Yeah, I'll do this side. Okay, whew, I'm done. That was a joke just for me.
For square root thing of x squared.
So what do you get here? 2 times 2.
4.
Yes,
4.
Plus
Plus
2x
2 of these.
squared.
I'm just foiling. That's all I'm doing, right? I'm not even really worried. I'm not trying to overthink it. I know I just foil it. All right? So 2 times 2, bam. 2 times this, bam. Then this times 2, bam. And then what's square root of something times square root of that same thing?
That thing.
Remember that? Square root of 7 times square root of 7 is 7. We had that discussion before. And it's really just to get you ready for this. So you're not making it look uglier. Square root of x minus 1 times square root of x minus 1 is x minus 1. Because it would be square root of x minus 1 squared, and the square root would cancel, right? We saw that before. What's the square root of 7 times the square root of 7?
7.
Yeah, because it's the square root of 49, which is 7. So skip the square root of 49 part. You know it just becomes 7. Some of you guys gave up earlier, just sort of looking in this direction, I can tell. But I really hope the idea of foiling doesn't care what's in it. You just multiply the first two, multiply these, multiply these, multiply these. I mean, it almost doesn't matter what's inside. Yeah.
I have one question. For the x minus 1, how you did that, and you got at the end, what if it was like x minus 7? Would it still be x minus 7?
Of course.
Okay.
Square root of RB times square root of RB is a whole RB. Good.
That clears it up for me.
His name's RB. So now, what do you think I want to do now? What's still not quite good in my whole equation?
Add the electrons.
Yeah, I can do that, but what's kind of like...
There's square root.
Yeah, there's still some roots in there. So I know eventually I want to try to get that by itself, right? So let's put our like terms together. Let's see, I got 4 minus 1.
3 plus x.
Let me put the x up there, and I got plus
4.
4 of these guys. I like it.
So you're trying to get the radical by
Trying to get the radical by itself.
move everything with you.
Kick ass. So you subtract 3, subtract x. 2x minus 2 equals 4 rad x minus 1. That sucks. I think I got some different answer. Too bad for me.
No, use square root.
No, I didn't.
No.
Divide by 4.
You could, but then you bring fractions into play, right? You see that? You don't have to bring fractions into play here. You could do one of two things. You could square exactly as it is.
Don't you add 2 to both sides?
No.
If I add 2, then I have to FOIL it, and I still don't get rid of my radical, right? I want to isolate my radical. I understand you could divide by 4, but then you get fractions over here. So I can just go ahead and square these things directly. Why am I not concerned about the 4? Because it's 4 times this. I can totally just square those pieces then, right?
Yeah.
So on this side, I have to FOIL this out. This is your new favorite problem. 4x squared minus 4 minus 4 minus 8x plus 4 equals 16. And what's the square root of x minus 1 squared?
X minus 1.
X minus 1. Then you get everything on one side, you get it equal to 0, right? What piece tells me I got to do that?
The square root.
It's squared.
I mean squared.
Yeah. Whew. We'll stop there. The rest of it's all in the answer key. I'm not going to give you one of these on the test, but I just want to show you what it looks like.
Oh, thank you. Oh my
The final
God.
one.
Thank you.
Bonus question?
I will put one on there.
You know.
Okay, okay.
Double duck cake.
That was an actual thank you, not a sarcastic thing. Most of the time I'm worried if somebody goes, why'd you put us through that? Well, because you're here to learn. Just because they don't grade you on it doesn't mean you shouldn't still learn it. But yeah, you're welcome.
Jeff, can we do one more or not?
No, let's go home. That's it.
Huh?
That's it. No, we want to. Yes. We could do several more. We got plenty of time.
Well, I have from my homework, but I need to explain them. E,
Oh,
Number
from.
1E.
Oh, okay, 1E.
please.
We've seen way worse problems than that, to be honest. Real quick, I'm not going to do that problem yet. Remember these kind of problems? What'd you have to do there? Get like terms, make sure everybody had it. Because this is an equation, I can kill the bottoms. So this 1E is an easier example of that, right? Because the bottoms are a lot less complicated. So that's from before. So now 1E looks like this. Thank you. So the y, of course, is over 1. So what does he need?
He needs,
Needs 3.
3, 1.
3, 1.
More than 3, because what does he need?
Needs 9. Oh, he needs 3.
He needs a 3, right? So I want everybody to have a 9 and everybody to have a y. So what's he need?
Y.
So now what does he need? 9y. Right? So it's like that problem, just not as bad, to be honest. And the reason I put this on there is I might put one on there on the test where you actually have to quadratic formula it next. Right? But the next step of this actually is factorable. But if you don't see you can factor, you can still use quadratic formula. Right, so here I can multiply both sides by 9y, so it'll cancel everywhere. So here I get 9y squared. Oh, I forgot to multiply this by 3 at the top. So this needed a 3 down here, so it needs a 3 up there. Equals. And again, just like the last problem, what tells me what I have to do?
The 9y squared.
Yeah, the square tells me I have to
Move the 20.
get that over so I get a 0 over there. Good.
Get
Believe it or not, that's factorable. If you don't see that it's factorable, you can still do A, B, C, do quadratic formula, right? I really would rather not do quadratic formula. How do you see if it's factorable? What do you have to do to try to factor this?
I don't know, for you, that real quick, can you, before you move the 25 over, I was thinking that you would just do the 9y squared minus 6, leave a space, equals 25y. That's the wrong formula?
No, it's perfect. You just had the wrong piece. You'd have to move the 6 out of the way and bring the 25y over, right? You have to have the middle term here. The middle term is what you cut in half. And what's the middle term always have as a variable? Y or x, just one of them, right? So these are like out of place for that. But quadratic formula is a shortcut to that. But you can still do that as long as you actually have the right thing in the right place, right?
So then you would multiply the 9 times.
Good. 9 times negative 6, negative 54.
And then what two numbers add up to 25?
27 by
27.
Good. 2 and 27. Oops. And to make it negative, which one's got to be negative? The bigger one. And then you break up you got plus 2y minus 0.7y minus, right? Break up the middle term, right? Remember this stuff? This stuff never goes away. It can always come up whenever the hell I want it to. And whatever the hell it does, right? And then, of course, the reason we do that is so now you can.
Add like terms?
Then we'll get right back to where we were. The reason we broke the middle term up is now there's how many terms? There's 4 terms, so now we can group it. Now again, you could, if you want a quadratic formula on this, you totally can. And that's the new thing we've learned. So if you don't see how to factor something like this, that's what quadratic formula was made for. But please, dear God, don't use quadratic on a simple factoring problem. There's no need for that. You should try factoring first. And this, oh, that's right, it's on the answer key. Let me go ahead and give you guys the answer key. It'll help me out a little bit. Is that one problem? Yeah, that's one C. Oh, okay. I just wrote it down wrong. Yay, Jeff. Yay.
Can you show us one of the problems that you do show work? That like you plug in.
Oh, you need to check your work.
Uh-huh,
Sure.
please.
And real quick, on 1C, in the middle of doing that problem, I'm like, that didn't sound familiar. I just wrote it down wrong. It's supposed to be square root of x minus 1, and I put square root of x plus 1. 1C, the one we were doing here. So I got to this point, I'm like, that didn't sound familiar. It's because I put a plus 1 there. It's my bad. So that's what I solved it as if it was plus 1. I made the problem, so I can change it now. It's just a mistake.
You didn't put plus 3. You didn't put the 3 in there.
Sure it did. I just subtracted it to the other side. I did it one step already, just to save time. You see that, Arvin? Okay. I like that though. So you want to do one like, let's do one that's a little bit easier than that. This is 3C light. So let's see. I've got to make it work now. Okay, that'll work. Yeah, good. So that we all should know now. And in fact, I love to give problems. And you'll notice on the end of the practice test, I did the same kind of thing. I mean, if I had something like this, I would first add 2. I isolate where my x is, right, first. So here I isolate the radical part first. I mean, that idea of isolating the part that has your variable in it first. For some reason, I suddenly had, last semester, I suddenly had a lot of people doing this. They would do this, see if you can see what they did wrong here.
Oh, they forgot the X.
And I don't know if they were doing that because they thought they'd get away with it, or it was legitimately they didn't realize it, but all of a sudden I had several people do that, but the X is still there. If it wasn't there, it'd be so much easier. I agree with that. But it's there. Right? So this is very cool. You gotta isolate the radical piece first. Then you do what?
Square it.
Yeah, that's why we isolated it. So when I square it, I don't have any side effects. It just kills that guy directly. So then I'm left with, and what happens on that side?
X squared?
X minus 1, X minus 1.
Yeah, so be careful. You always got to foil that piece, right?
So we will have the danger.
Danger will work. So. How are we doing there? Is that cool? Okay, and And then, again, what tells me what to do here?
We can do minus 1
X squared.
Yeah, I mean, you can. It's part of everything. So subtract 2x, subtract 1, subtract 2x, subtract 1. I like this problem. I didn't make it like this on purpose. Look what happened there. Does that freak anybody out? It shouldn't.
Just factoring.
Yep, factor it. It's true. But do I put parentheses down to factor it? No. What form of factoring is that? Yeah, GCF. What comes out?
X.
Everybody tries to enforce it like that. If it's two terms, it's a special case somehow. It's either squares or cubes. It ain't none of that. Because I only got one x there. It's not a square or a cube. So it must be just GCF. And that's why I always tell you to try GCF first.
X
To
minus
save yourself from this kind of problem. So yeah, take an x out.
minus 2.
X.
Yeah, just take an x out, right? So then how do you...
X equals 0.
Yeah, either this is 0. That's beautiful. That's an answer already. Possibly.
Minus
Or...
4.
X is 4.
So now I got to check them, right?
Yes.
You always have to check your answers to a radical equation because when you square both sides, you've changed it from negative to positive possibly. That's why
Only on
math gives us
radical,
more
right?
answers.
Only on radical. If we have to
Well, yeah, on radical equations and what other kinds of equations have we hit? We got to check.
plus and minus.
Rational, remember when you have like over x plus 1, you better not get negative 1 or else
Oh, yeah.
it's going to make it freak out. So there's those kind of problems where I got to check the answer at the end. So yeah, if we try 0, what do we get? We get square root of twice 0 plus 1 minus 2 equals 0 minus 3. Is that true?
Yes.
1
Square root of
minus
1 minus 2, is that
minus
negative 3?
Yes.
1 minus 2
No,
is negative 3?
It's 1.
No. 1 minus 2 is negative 1, right?
Yeah. Negative.
I like that reaction. You guys see that?
Mm-hmm.
I mean, a lot of people are telling me yes, 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 but that's so completely no. 1 minus 2 is not negative 3. If that would have been a negative 1, that would have worked, right? If that would have been a negative 1, that would have worked. And that's what we do when we square both sides. Math loses information about what the sign was, and that's why it thinks there's more answers. So it's not math's fault. Yeah.
I don't understand it because the 1's being squared and then minus 2, so you can't subtract those, right?
No, no,
They're
no.
not-
What is the square root of 1?
1.
1. And then you can do 1 minus 2. And then it's not negative 3, so that's why I threw that one out. But you're right, if I left it as square root of 1, I couldn't do that. They wouldn't be like terms. But the square root of 1 is 1. Cool. Yeah.
Can we do okay.
We're not done here yet.
So you just take the 0 as one of the answers, and then whatever number is in the parentheses that is being subtracted from x. That's the other answer.
I don't know
Why is
yet.
it
I don't
4?
know yet. We gotta check it.
Why is it 4, not negative 4?
Because what makes it 0?
Oh, gotcha.
Yeah. Alright, so now if I check 4, square root of twice 4 plus 1 minus 2 is that 4 minus 3. Square root of 9
It's 3
minus 2 is 3 minus 2 is 1. Check. Okay. So then it is 4. So make it very clear. Cross that out. I think somebody... Okay. Oh, 2A. Did you have a question about this one?
No, I was going to ask about one of the word problems.
Okay, so this is the completing, now this is the completing the square problem, right? I think I warned you about this, that I like to give a problem where I ask you to do it 2 different ways. So you know that's probably going to show up on the test. So this is 2A. Yeah, so whatever you want to do first. You want to do quadratic first? Alright. And I got to ask this, did it not make sense on the answer key, or have you...
Oh, no, but I'm lost even in my homework, so it's going to be the same thing, but we're going to do it, because I have a homework question too.
Okay, so what's
So
A, B, C?
The same.
1, -6, 1.
What?
Yes. And you got to know the quadratic formula, of course. Right? So how's that?
Square B.
B squared
minus 4AC over 2A.
Sorry, I love it. Square. 4AC. Right. I've seen some really dorky YouTube videos with the whole class making a song about it. I'm like, oh my god, I don't think I'll ever make you do that. So what's negative B?
Minus 6.
C is negative 6. Yeah, so that'll be 6. Give or take. Negative 6 squared is? It's not negative 36, right?
No.
That first number is always going to be positive because you're squaring a real number.
Mm-hmm.
So for some reason, I'll get somebody to give me that the negative's still there. No, it's dead. I squared it away, right? Minus 4 times 1 times 1. All over twice.
So 6 plus or minus 32 over 2.
Good. 6 plus or minus square root 32 all over 2. Is there any part of that I can do something with?
6 and a 2. You should be able to or not?
3, yeah.
Not really.
Maybe 30.
Unless you're doing something else at the same time.
And you can reduce the square, right?
What's being divided by 2?
The 6
The
and
6 and the root 32. So I just want to make sure if you do this and that escapes it, you've changed the problem. It's not good.
So that's the bottom.
No, it's not.
Can you split it up to where you could have the 6 plus or minus?
Sure, you could. You
Can
could. You could.
do that?
There's a slightly more important thing I want you to do right now, which is what can you do with radical 36? Yeah. So it's
4
6.
times
Something even better than 4 and 8.
It's 16 times 2.
16. You always try to break it up into the biggest square you can think of. So 16 is square rootable, right? And why is this a little bit better than what you guys wanted me to do? Because
It's
4.
4 add 2 over 2. And now I just divide everything by 2.
Yeah. 3 plus 2.
I went through that a little quickly, but it's all on the answer key. Is that cool? I don't know if there's a spot that messes you up or...
You don't have to divide the 2 into the red 2 thing?
Tell me this. So look, you're looking at this piece, right?
Yeah.
All right. Now tell me this. What's 4x divided by 2?
Is
2x.
Okay, you didn't have to divide 2 into x. No, x doesn't get its own 2. There's only one 2. Once it divides into 4, it's gone. So once that 2 divides into 4, it's gone. Right? Do you understand? Once that 2 divides into 4, it's gone. There's no other 2 for the rad 2 to have to worry about.
Oh, I see.
Plus, you couldn't even divide the 2 into rad 2 because there's not a radical on it. But you don't have to worry about that. There's not another 2 for this guy to get anyway. Is that cool?
So you treated the radical
As an x. And we've done that before. And you don't have to remember when you're allowed to do that, but when it's 4 times rad 2 divided by 2, you're allowed to just cancel the parts you can. We've done that before. Right? So since I don't know what rad 2 is, sure, in a lot of cases you can look at it like it's x, because I don't know what x is either.
But if we had plus or minus there, that's not.
No, then you couldn't do it. Then you have to split it up. Yeah. At most, yeah. Alright, so what about the other one? What about doing this, completing the square way? No, what we just did was quadratic formula. Right? What's the first thing I should do?
Divide negative 6.
No.
Move the 1 over?
No?
I don't,
Oh,
you might
move the 1
use,
over. Yeah, move the 1 over. Sorry, minus 1.
yeah, but then, what do you mean divide negative 6?
Sorry, I meant to split the 6.
Cut it in half.
The
Cut it in
first.
half. Cut it in half.
And then it's a coordinate.
So then it's 3x.
Yeah. You got it too, okay. And then the second step?
Square it. Square the 3. Negative 3.
So what goes here?
9.
9. So the second piece kind of goes back here, and this piece tells me how it's going to factor, right?
X minus 3.
You have to put it outside.
Oh, I forgot over here.
Yes.
Plus
Eight.
9.
Good. So if you add 9 to this side,
Yeah.
you add 9 to that side. Good.
So 8.
8 on the other side.
Sweet. All right, let me stop there for a second. Is that cool?
Mm-hmm.
You make room, because you know you got to put something there. You make room, get at it. And then you cut the guy in half, square. That's what goes there to make this work like that. That's what goes there to make this work like that.
That means we just factor in the top, correct? Because x minus 3 is factoring the whole thing.
Yeah, that factored is this. That's right. And then, of course, what can I do now? Why did we do all that?
You do a square
Because
root.
now I can attack this whole thing as being squared. I can attack it directly with the square root.
Plus minus.
Plus or minus. Die. So what's here?
X minus 3
3.
equals plus minus square root of 8.
You got to do 3 of it.
4.
No, it's going on.
Well, I can only do so much at one time, Carl.
4 square root of 2.
Yeah, so two things. Like Carl said, we should move that 3 over. Add the 3 over. But then what can I do with the rad 8?
4.
Rad 4. Rad 2. So I get 3 plus or minus 2 rad 2. Does that look familiar?
Yes.
Yes, it looks like looks like that one.
So either way it's correct.
Yeah. So it all depends on which way I ask you to do it. So there could very well be a problem where I ask you to do it both ways, which is kind of nice because then you know what the answer is. This problem I ask you to do it both ways, right? The quadratic formula way and you continue the square root. If I just say solve this, you can do it either damn way you want to.
Are you going to be specific on the test?
Oh, yeah. You know it. Alright, so I want to spend a little bit of time with that. The last thing we did last time.
Oh, can you go ahead?
Yeah, please.
The word, one of the words.
Or not. I'll just test you on it and not really go over it again. No?
No,
Yes?
The number 5.
You want me to go over it?
Oh,
Okay. Yeah, the negative b over 2a thing?
it's gonna be on the exam, right?
Yeah.
Yeah, because I don't have one going.
So if I give you what you got, Jeff?
It was 13.8.
That is for the vertex.
13.8.
Sorry?
Was it 13.8, the section?
No, 13.8 was the extra credit. So like number 5 on the practice test was from the extra credit section. So if that gave you trouble, the house and the fencing query with
13.7
dog.
and 13.8 are extra credit?
No, 13.7 is not extra credit.
It was 12.7 extra. credit.
12.7 was extra credit, yeah.
I think you're mixing.
Oh, okay.
Yeah, yeah. Alright, so how do I find the vertex? What's the quickest way to find the vertex?
Minus b equals 2a.
Well, no.
You said the quickest.
So
Look at
the
the negative 2.
no, I did say the quickest, but you didn't quite say it right.
Okay, we have to take out the 3 and put it.
No.
Oh,
So the negative 2.
Well,
Use a negative 2 for the 1.
vertex.
Good. Okay, that'll be the y intercept. Vertex. What's the shortcut to find the vertex? You had the pieces just in the wrong place. So the vertex is in the form x, y, right? The vertex is a point, right? It's going to be somewhere in the plane. It's a point. So the shortcut starts with telling me how to find the first part of the point, and then I just take that to find the second part of the point, right? So the whole idea that I kept developing was the vertex, if I know the intercepts, the vertex will be right in the middle. So intercepts can always be gotten by using the quadratic formula. I can always use quadratic formula to make it equal to 0. We factor it if we can, but we can always use quadratic. And what's always in the middle of the quadratic formula? Negative b over 2a. Right? Because the quadratic formula again is negative b plus or minus stuff over 2a. So if I break it up, it's negative b over 2a plus or minus stuff. So that's in the middle. Negative b over 2a plus stuff, negative b over 2a minus stuff. So what's in the middle? That guy. That's the guy that I added and subtracted. So he's going to be in the middle. That's going to be where the vertex is. He's going to be in the middle.
So if I have a parabola and I know its intercepts are here and here, I know the vertex has got to be somewhere here in the middle. Maybe it's right there, and then it opens down. But it's got to be right in the middle of these two because the parabola is symmetric.
This might be kind of stupid, but if the negative b is already negative, then if, like, say the...
Well, then you just plug in what b is. So if that was negative, it would be negative, negative 12.
It'd be positive. It'd be
Yeah.
positive.
Same thing you do here.
Gotcha.
Yeah. So the x piece, I can get it through the shortcut, which is negative b over 2a. Even if you don't understand my desperate attempts to explain where it comes from, using it is really easy. It's like quadratic formula, which you all are able to do, just better. You don't even worry about the radical part, right? All you gotta know, what's b?
B is 12.
12, right? Just because it's in the right place. And what's a?
Negative 3.
Negative 3. So what's negative 12 divided by negative 6? Positive 2. I like it. The negatives go away. Right? So I already know half of my vertex. I know it's got to be a 2. It's a 2 somewhere in that place where x is 2. How do I figure out what the y piece is?
With the minus 2.
Yeah, you plug it back in. This is y, right? So what's f of 2? Negative 3 times 2 squared. Plus 12 times 2 minus 2. Just plug it back in. Once you know x, I don't care where the hell you got it from, to get y, you plug it in. So what do you get here?
Negative 12 plus 24 minus.
So you get 12 minus 2. Careful. Yes, positive 12, yeah, careful. Positive 12, right? Minus 2 is 10. So my vertex is 2, 10. That's the vertex. And somebody help me out. Is it open up or down?
It's going to be down.
Open it up. Bottom, right?
What's positive?
It's the numbers.
The
No, the
negative
vertex could be any damn where. If it opens up or down from there, it's another piece of this.
It's gonna open down
It's gonna
because
open
it
down.
has a negative sign.
That's negative, so it's going to open down.
It gives you a maximum, right?
Y equals x squared opens up. Y equals negative x squared would have negative outputs. It's going to open down. So you can always look right there to tell me if it's going to open up or if it's going to open down. But watch this. Watch this. You don't even have to know that, to be honest. You ready? So if I ask you to graph this bad boy, just like on the practice test, how do you find the y-intercept?
Making x 0.
Yeah, so if I make x 0, what do I get? I get negative 3 times 0 squared plus 12 times 0. Which is a lot more work than I need, right? If I make x 0, I just am left with whatever the hell that number is. Cool. So then the y-intercept, I don't know the way you guys are looking at it. There's nothing new there. How do you always find the y-intercept? You make x 0, period, right? And that's why, in this formula, for example, what's always the y-intercept? What's the y-intercept there? B. Why? Because when you set x equal to 0, what do you get? You get b. That's why. Whatever number's there must be the y-intercept, because that's what you get when you make x 0. It's kind of, yeah, right? So to find the x-intercept, to find the y-intercept, you make x 0. To find the x-intercept, you make y 0. Right? So now I know that y-intercept is 0, negative 2. Let's try to graph this bad boy. We only know a couple things about it. We know that the vertex is at 2, and let me go by 2s here. 2, 4, 6, 8, 10. Is that cool? Okay, it's cool. And then my y-intercept is at 0, negative 2, right? So here's my y-intercept. Where's my vertex again?
210.
Yeah, 2, 10. That's my y-intercept. Now, here's the cool. And so I already know, I don't even have to realize that negative means it opens down. It's got to open down, doesn't it? That's the vertex. So it's got to go like that. Can anybody tell me the position of one other point without doing any real work?
Negative 2.
What about it? So here's the mirror, right? Here's the mirror.
just count.
This is called the axis of symmetry. That's where the mirror would go, because I know it's going to be symmetric. If this guy is 2 away, there's got to be another point 2 away at the same level. That's the mirror image. Parabola is symmetric. It's got to have a mirror image point there's got to be mirror image, mirror image, mirror image, mirror image. Mirror image, mirror image. You say that enough, it sounds weird. So I got the y-intercept, go through the mirror. I got the other point there. And then I can make my parabola. Wow. Make that big in this spot. Wow. I get my x-intercepts there. I can get approximations. I don't want to worry about that.
Can you say that one? What makes it open, down, or up?
Two things. That's a negative there, right? So the most basic parabola is like x squared. So 0 squared is 0, 1 squared is 1, negative 1 squared is 1. Cool. But if I made it y equals negative x squared, now all the outputs are going to be negative. So then it would just be like that. So whatever that thing in front is, that tells me if it's going to open up or down. But the minute I put my vertex and my y-intercept, I knew it had to open down. That's the only way it's going to actually get there. If my vertex is there, and my y-intercept is there, it's got to open down. So it can actually get there. If it opens up, how the hell is it going to get down there? There you go. So you don't even have to know about it going into a problem. You can see it halfway through.
From the onset, when you see the problem,
You can tell from the beginning that it's going to open down. But even if you didn't notice that, it'll still come out in the work. Cool. Let's do one more problem. And real quick, if this was your profit function, and this is like in thousands, how many cups of lemonade do I have to sell to maximize my profit? 2,000. 2,000 cups of lemonade. So maybe I'll be down there sometime. But if I sell 2,000 now, I'll be at my maximum profit. So I mean, that is true. I want you to really realize, financial analysts. My best friend Sean is a financial analyst. He was at Dell. Now he's at American Express. Whatever. His job is to adjust the equations that matches how much money you're going to get based on the demand in the market and all that kind of crap. Right? His job is to adjust the equation, so he keeps telling him, we need to shift this part this way, we need to shift this part that way, we need to change that this way, and that'll maximize our profit. And every day it's changing, so he's always changing. That's only one part of his job, thank God, because I could never do that job, but you make a lot of money. But that's what he's doing. He's adjusting the equation, seeing where the new peak is, and saying, we need to move things there, we need to... Do you guys kind of see what I'm saying? That's why they get paid so much. If you're really good at your job, the company's going to do really well, right? You're going to constantly be adjusting in the direction of making the most money, which I don't care about, obviously, because I teach. Yes?
Hopefully this is not anywhere near our class happening, but now that parabola, if it hit a bottom and curved back up, what would that be called? It's got to be a name for that. Still a parabola?
No, of course. This shape is a parabola. This is a down parabola. You can have an up parabola.
Well, what if it went down and up?
Oh, I see. Then it could be a cubic.
Is that what it's called?
Yeah, so see how this is squared and it's got one term? Cubics could have 2 terms. So if it's to a 3rd power, you can have at most 2 terms. If it's a 4th power, you can have at most 3 terms. So a classic 4th power would look like this here. 1, 2, 3 terms. So of course, in reality, his equations are not that simple. His equations are, more like, and then you just, if it's impossible to get over there, then you forget about that. You're like, but we can at least be there. You look at your second highest peak and so forth.
What math is this?
That's actually pre-calc, is what that would be. And then calculus is really, really where you learn how to maximize analysis of it.
Is that because you have to account for that with the cubes and all that kind of stuff? Where exactly?
Why is it the number of terms?
Yeah.
I'm not going to get into that right now. That's a pre-calc topic. Okay. Yeah. Okay. And actually, until you get to calculus, you really don't fully understand.
Oh, well, then let's drop that idea for a while.
Damn. Yeah.
So we will not get a one problem with this?
No, that was from the, it'll be an extra credit question if any. Yeah.
This, not this.
No, this will be a normal question. The dog in the backyard of your house and stuff, that'll
I
be.
wanted you to go over that one.
Well, it's on the, it's on the, didn't I do it? Did I?
Yeah.
Yes, I did. There.
It's on the answer.
Okay, I went over it. Sorry, it's been a long one. Let's do one more of these. Let's do one that's open and up here. Let's see. So let's just get this out of the way first. The most immediate thing I can get is the y-intercept, right? Can you guys do that real quick without having to do much work? What must the y-intercept be?
11.
Yeah, it's got to be 11. It's just like mx plus b, except there's one extra term. But when I make x 0, the only thing left is the dude that has no x on it, right? He's like, x don't affect me. So he's still alive. There he is. So now how do I find the vertex?
8 over 2 times 2, which is 4.
Yeah, so the shortcut is negative b over 2a.
Negative times negative a
Good, so negative 8.
divided by 2
Times 2.
times 2,
So that's 8 over
4, which is 2.
So I know the first part of my vertex. And then I take f of 2 to get my y piece.
2 times
2 times 2 squared minus 8 times 2.
2
Yeah, 2 times 4 is 8.
minus 16 plus 11. 0.
8 plus 1.
-5. Oh, no, I'm so sorry. I didn't see that.
Okay. I didn't take it personally. Alright.
Wait, where'd you get that y equals?
Well,
Okay, you plug the
yeah, just plug a 2 in to get y. Because what did this take the place of? So to get the y piece of the vertex, I just plug 2 into the function.
Okay, so you solve, first you solve for the x,
Good.
using that formula.
The shortcut.
Negative b over 2a, and then you come up with an answer.
Good.
And that answer.
It's only name.
You plug it back in to see what
To
y.
be
Got it.
y,
You plug it back in to see what y is.
to see what y is.
And that's your
So
vertex.
the second one is your y equals the f and then you.
Well, that's what we're doing. We're plugging the 2 back in
Okay.
to see what f
I was
what
writing
y
something like
is.
kind of.
And so there's my vertex now. 2, 3. So I know my y-intercept is 11. 2, 4, 6, 8, 10, 12. So my y-intercept is 11. And I know my vertex is at,
2, 3. He just put it there.
I'm sorry, 2, 4, 6, 8, 10. So 2, 3. Yeah. So since there's a point here, 1, 2 away from this, there's got to be another point.
4, 11.
Between them.
Yeah, 1, 2 away. So it's got to be a point right there. Mirror image. Now let's check it out real quick. Let's check it. Supposedly, let me take all those arrows out. So here's the mirror, right? That's the symmetric line. My parabola's got to be symmetric. So since I know it goes like this, there's got to be another point, mirror image on the other side to make it symmetric. So supposedly it goes to the point 4, 11, right? So if I plug a 4 in, Jeff, make a 4. There it is. What do you get when you plug a 4 in? Yeah. Twice 16. 32. Minus 32 plus 11 is 11. Yeah, so you can check that other point.
Do we have to check it? Or not?
If you want to. Yeah. Now, what would the x-intercepts be for this?
The x-intercept?
Yeah?
There won't be no.
There wouldn't be any. In fact, if you did the quadrant, if you tried to set this equal to 0, you would get complex answers because there are no real x-intercepts, are there?
No.
It starts off below the x-axis and goes up, so it doesn't hit the x-axis at all. So that's why sometimes when you solve these, they come out imaginary. Visually, it means there would be no x-intercepts, no real ones.
I did that for one of the problems and I got I. I'm like,
There you
what
go.
do I do with that?
That's what you do. You realize it's going to go away from the y. It's going to start below and go down. So it just never hits the x-axis.
Okay.
Did you correct the history sections?